Swayam Prabha. Digital India. Educated India.
Let's get started on today's class on causal loop diagram. We introduced very basic concepts on systems thinking and system dynamics, and characterize that in this course we are going to be looking at the dynamic behavior of systems, looking at causal loop modeling, and then stock and flow diagrams to understand accumulations, and thinking endogenously. These are the four concepts we discussed as basics for system dynamics modeling. Since the underlying theme will be to look at things that evolve over time, that is a dynamic behavior. We will be starting with one of the first pillars of that, which is the causal loop modeling. So, let me introduce you to that. So, causal loop diagram. So, basic idea here is the causal loop diagram is nothing but a visual representation of the cause and effect relationship between various elements of system forming feedback loops. That is how it is at least written on the board. The purpose of this CLD is threefold. One is to conceptualize the problem, understand what it is about, and communicate with others. That is the first and last point. And the key idea is to capture the hypothesis about the causes of dynamics, understand what are variables in the system, see how they are linked with each other, and through that visual representation see how we can explain how the system is evolving over time. So, that is the entire idea of this developing this causal loop diagram. In that sense, it is slightly different concept because this is one of the first course is looking at the actual modeling of any system. How do you identify the variables, how do you identify links, and once you establish those relations, then we can later study how to come up with the equations underlying the system. So, first is just to identify relationships between the various variables within a system. CLDs or causal loop diagrams, CLDs in short, nothing but consists of variables connected by causal links or arrows. It is not very difficult to visualize. We just have an x which is affecting y, or x influences y as we read it. The variable at the end of the arrow, or the x, is independent variable, and y is a dependent variable. There is nothing, it is kind of straightforward there, and the arrows show the direction of causation. So, we can illustrate with very simple examples. So, for example, we can identify variables such as say births and population, or deaths and population. Here we can say, okay, birth influences population, deaths also influences population. We could, so we want to read it as births influence the population, deaths also influence the population. Here, and we can construct many such examples like production affects inventory, sales also affects the inventory. To elaborate on that causal link, we can associate it with a link polarity. We use the symbol plus or minus. Plus indicates it's a strengthening, and minus indicates it's a opposing. S can stand for same direction, O for the opposite direction. So, let me go back with that idea. to the same examples. Here what we want to do is we want to visually represent how the births affects the population. As more births happen, the population increases. So, as more births happen, population is also going to increase. So, it is in the same direction. We indicate it by a symbol plus against the causal link. Yeah, by the plus here on the causal link. Again, deaths, as more deaths happen, the population falls down. As more deaths happen, the population falls down, right. So, as deaths increases, the population falls down. So, that we can indicate by a minus sign against the head of the arrow. So, this gives us an idea that okay, as deaths increases, the population falls down, or births increases, the population increases. So, just these simple concepts, we can establish a nice causal map of various problems that we can look at. So, we can go back to this example. Now, as more production happens, the inventory on hand should increase, correct. So, that we can indicate it by a plus, and as sales happen and inventory decreases. So, sales increases, my inventory is going to decrease. So, I am going to put a minus sign against sales and inventory. This is a very simple example on plus and minus. So, we can, as more population occurs, more births occur. Yeah, we can do that. So, we can put an, to indicate that, we can close the loop by adding this population and birth and have a plus sign here. So, we can reconstruct, the similar thing will happen with deaths also. So, we can extend this idea simply here. Let us write it, births, population, deaths, as more births happen, the population increases. So, same direction, let us use the symbol plus. As more population is there, more births will also occur. So, direction is still the same. So, we will put a plus. As more population is there, we can expect more deaths to be there, right. They share the number of deaths. As population increases, the deaths can increase. And as more deaths are there, the population is supposed to come down. More people die or more, whatever the population of whatever community or species you are looking at, that population has to come down. As more births happen, population comes down. You can indicate it by a minus sign right here. So, what we have just drawn is it's not just the causal link, we have even moved ahead and drawn a causal loop. As you can see, we had drawn our first simple feedback causal loop here, and there is loop here. If you look at the loop on the left side, here as births increase, population is going to increase, as population increases, births further increases, etc. It keeps on going to increase. In fact, it will increase exponentially. So, this entire loop is what we call as a reinforcing loop. Well, if you look at population and deaths, as population increases, more deaths happen, and more deaths happen, population decreases. At some point, it can reach some sort of a equilibrium, can be expected there. So, this loop is called as a balancing loop. So, there are two types of loops, one which we can expect an ever increasing behavior influence of births on the population, and as population increase, deaths can increase. which kind of limits the growth of the population. So, that loop is called as a balancing loop. Examples ought to work. Suppose we have two variables, just say x affecting y, we can have various kind of relationships, just to put a numerical sense of things because we are used to that. Suppose we take the first case where say x affects y, and the relation we give as x is equal to, so y equal to 2 times x, right. Very simple example. Suppose in this case, suppose the value of x is 1, y is 2, as x increases here from 1 to 2, y is also going to increase to 4, as this goes to 3, this goes to 6, etc. But as y comes down, see x comes down, say from 1 it comes to 0.5, this is going to come to L1, right. As this comes to 0.25, this comes to 0.5, etc. Still that is a decrease. So, if we can take this as a reference point. So, initially started with x as 1 and y take the value of 2. So, as x increased from 1 to 2 and beyond, y will also continues to increase from its reference point of 2. If x falls below from 1, y also falls below 2. So, the direction of movement is the same. So, if direction of movement is the same, that is the case we indicate this link with a plus sign. Let us take I know I am using different colors, but it is fine. Let us say, let us do x by 2. Again, let us take the same reference point. So, when x is 1, y is going to be 0.5. So, when x increases to 2, y will take a value 1, x is 4, y is going to take value 2. So, as x increases, y continues to increase, again this is our reference point. Let us see, as x falls down, so instead of 1 it becomes 0.5. So, y will be 0.25, right. So, as x falls, y also continues to fall. So, we are just, it is still multiplying by constant, right. Instead of multiplying by 2, you are multiplying 0.5, still multiplying by constant, the direction of movement is the same. So, we continue to represent it by a plus sign, so x influence y, the positive direction. Right. So, these kind of things can lead to some tricky behaviors, that is why I explained it. So, let us take up the third case, say x influences y. Let us take y in this case equal to 1 over x. Okay. Let us again take the same reference point as 1, y is 1, that is the same reference point. So, as x increases 2, y becomes 0.5, x goes to 3, y becomes 0.33, x becomes 4, y becomes 0.25. Here you can clearly see as x is increasing, y is decreasing, correct. Now, let us see what happens in the opposite direction. As x becomes 0.5, y becomes 2, and so on. You can expand the case. Okay, just to make it understand. So, here it was relative movement. So, to indicate this kind of relation, as x increases, y increases. So, then we do a plus sign, or x decreases, y decreases, it is a plus sign, same direction. Other option where x increases, y decreases, or x decreases, y increases, it is an opposite direction or opposing, we indicate it by a minus sign. Okay. This is a very simple artifact of us using the thumbs. It is a simple trick, but if your thumbs are in the same direction, that means a positive link. So, x increases, y increases, or x decreases, y decreases, then it is plus sign, if x decreases, y increases, opposite direction, then it is a minus sign. Okay. So, here plus and minus are just symbolic, it is nothing to do with addition or subtraction, it is just symbolic to indicate the direction of causation. Okay. So, that is the simple idea. Just to go over what we did, if you want a formal definition, if all other things being equal, a change in causal variable generates a change in the same direction in affected variable relative to its prior value. That is the kind of formal definition of it. But if you want to get a feel of it, it just says that if x increases, then y increases above what would have otherwise been, or if x decreases, then y decreases below what it would have otherwise been. So, that is what it simply means as a plus sign. So, in this course, we will be using the symbol plus, but there are some books and papers which use the symbol S instead of plus, but that is very few. Most the general convention nowadays is just use the symbol plus. But minus, if all things being equal, a change in the causal variable generates a change in the opposite direction of the affected variable related to its prior value. That is, as x increases, y decreases below what it otherwise have been, then we use the negative sign or a minus.